Hello and welcome everyone to the first of our Secure Guardrails workshop series. This is a series where we're going to talk about how to incorporate secure guardrails into your application security program using the context of a specific vulnerability class. If you're not aware ahead of time, the class for today is XML, External Entity Injection. So hopefully you're all super excited to talk about XML. Today, who are your presenters? I'm Jason Kinsfather. I'm a solutions engineer here at Semgrep. I've been here over a year now in the application security space for longer. I'm joined today by my wonderful colleague, David Whitlow, who is a senior solutions engineer here. He'll be helping out in the chat. So if you have any questions, comments, he'll be helping answer those. If you want to just throw them in the chat there. And with that, who are we? But also, what are we going to do today? Today, we'll talk a little bit about what are secure guardrails, how do we use them, how can we take a strategic approach to kind of rolling them out. We'll discuss composing rules for secure guardrails with Semgrep, specifically tackling the vulnerability class XML external entity injection. And then we'll talk about how Semgrep can help you enforce guardrails with Semgrep code. If we have any time left, we'll have a Q&A session. But with that, let's get started. So who are we? Who is Semgrep? If you're not familiar already, we are a static analysis, software composition analysis, and secrets scanning company with a mission to profoundly improve software security and reliability. And the ethos that really guides us on the path to accomplishing this mission is the belief that due to the fact that security is often understaffed and under-resourced, and with the speed of development just rapidly increasing every day, the best way that we can enable these profound improvements is by helping security scale. And the best way, in our opinion, to scale security is with the help of secure guardrails. Now, it's important for us to contextualize secure guardrails within another long-standing application security buzzword, which is shift left. Shift left as a movement was useful. It made sense to kind of have a backlash to the really reactive role that application security testing used to take within the software development lifecycle. But now every application security tool, even your granddad's like slow old SaaS tool, all claim to shift left and can help you get a little bit earlier or more in the software development lifecycle. We can now get alerts at build time or at pull request or even in the IDE. And if we look back at shift left's legacy, we can see that the reasoning was pretty sound and the intentions were true, but it hasn't all turned out to be like milk and honey in the promised land for companies that have employed shift left tactics. As it turns out, just interrupting developers earlier in their process hasn't had like perfect results. And there's a few reasons for that. There's a real misalignment in the incentives that developers have. They're trying to move fast, they're trying to ship features, and that's their primary, their P0 motivator. Security, probably not second on that list, probably not third. They're trying to move fast, and ultimately, security needs to be built in, but it's not something that they're focused on. And it's not that they don't care about security, right? Security bugs are bugs, and as a developer, I don't want to write buggy code, but writing secure code is difficult. And often developers don't have the training or knowledge to triage code, review it, or fix security issues. And that becomes problematic when we're just surfacing a whole bunch of issues at them in the IDE, at the pull request, at build. Sure, we're shifting left, but we're spraying them with false positives. We're asking them to kind of context switch out of their workflow and say, hey, here's this really crazy like injection issue. Can you go and triage it and figure out like, is it legit? And where are the opportune fixes? So now they're going in Google, they're going in Stack Overflow, they're knocking on the door and asking their pal ChatGPT for help. And so it really kind of leads to, at best, some issues getting a lot of time put towards them and the rest kind of getting ignored. And at worst, developers getting annoyed and just kind of turning stuff off and ignoring it altogether. Because it's a poor experience for them. And ultimately, it's a poor outcome in security perspective. So it's not enough to just get things in front of developers early on. It's important that we lower the barriers to developers, that security makes the results that the developers see super relevant and easy to both review and also fix. And that's where secure guardrails as a concept really comes into play. Secure guardrails are a way of helping nudge the developer to choose the secure option when they're coding, so that as they go along, it's a pretty like easy choice. You're doing the insecure thing. Here's the secure thing, and we'll get into what that means and kind of what that looks like. So when we're trying to like approach strategic guardrails as, or sorry, secure guardrails as an organization, there's a few different tactics that we can take. If you're using a tool like Semgrep, you'll have secure guardrails out of the box, but sometimes you want to take a targeted approach to your program and a real intentional strategic approach to kind of eliminating some of the bugs that you see on the regular. You know, take Riley, for instance. They work at a company called Capital Gains Group, which is a large financial services company. They're a company that exchanges data with a whole bunch of different financial partners. And all those partners, they're dinosaurs that, they only send and receive data in an XML format. And so that's the core of their like data processing is XML. So when they're approaching the kind of like, what are the risks and kind of issues that they're dealing with as a security team, this is something that crops up again and again and again. And you yourself, looking at your organization, you might want to select a vulnerability class to target and try to eliminate. And there's two approaches to that. The first is, of course, like, well, what is the biggest risk to the organization? What if we eliminate will, lower the risk that's posed, or threats that are posed? But the other way to approach it that I also see pretty common is, what are the vulnerabilities that your team is spending the most time on? Like, are there really common vulnerabilities that keep cropping up and again that your team has to engage with developers because they're confusing or whatever? If you eliminate those, will that then free up your time to focus on the things that actually matter? So that's one way to kind of select a vulnerability class. And then you want to try to implement some secure guardrails, just a very simple guardrail, just to try to see both like what you can get in place to help the developers. As a more advanced tactic, which we'll also explore today, you could try designing and delivering a secure default to the devs so that they have something to reach for. And you can enforce that with a custom secure guardrail. And with any program, you want to measure adoption, which is, how we know that we're doing a good job. So, we're trying to be strategic in how we approach our program. So why might you want to prioritize XML external entity injection? If any of this applies to your big high value applications or components, do they work with sensitive or high value data that would be bad if it was exposed? Are these systems within a trusted network, and that network has other resources that they potentially have access to? Also, do you have some kind of, maybe you've legacy systems with custom XML parsers that really haven't seen the light of day of development in a while? Or you just still exist in an environment where there's a whole bunch of user supplied XML data that's being, kind of coming back and forth. So those could be some good reasons. Here Riley works for Capital Gains Group, and so they're going to choose to prioritize external entity injection. So we'll talk a little bit about the kinds of rules that we can kind of deploy to tackle a vulnerability class. But to get into that, we got to put our kind of like nerd hats on and get into the nitty gritty of XML. So I'm going to give a series of examples using Java to talk about kind of the XML parsing in Java. So what is XML external entity injection, or XXE? If you're not already familiar, an injection attack like this occurs when an XML parser is given a XML structure that has been deliberately and maliciously crafted by an attacker. So when it gets parsed, There's a reference that the attacker has added inside of the XML that gets dereferenced when it's parsed and brings in data that the attacker is not supposed to be able to access. So they could bring in, sensitive data from elsewhere. They might be able to contact other systems that the application has communication with. They might also be able to store things on the server side, some kind of arbitrary code that could be executed in a future situation. So, the only limits there are your kind of evil imagination, but that's the gist of it. So you're like, yeah, that sounds pretty bad. Thankfully, the XML parsing landscape in Java should be like super simple, right? Well, you'd be wrong. Java XML parsers are a bit of a mess. When it comes to like XML in general, there's multiple different interfaces that you could be using. I'm listing 4 here: DOM, SAX, Stacks, and XSLT, but there are at least like 18 or more. And they're all implemented by different classes. So I'm listing some of them here. And then the other cool thing about that is for each of these classes, they have different security settings that could be turned on or off. And each of those settings could or could not protect against a certain combination of attack vectors. So there's 10 different ways that an attacker could include external content in XML. And so, we're going to try to focus on, just to kind of narrow down the scope of all of this, we'll just focus on a single XML parsing class, document builder factory, which uses the DOM interface. So we'll show examples for this class, but if you're interested in some of the other XML parsers and how to secure them, a lot of the content in this workshop is from research done by our security researchers, Peter Kremer and Vasily Ermilov. And they have a cheat sheet for 9 other XML parsers, if you're curious. So when we talk about like what a secure guardrail is as a kind of rule, a secure guardrail as a rule differs from the typical kind of static analysis rules that you're used to from a traditional SAS scanner. And those are what I would call vulnerability detection rules. So when we're looking to detect a vulnerability, in the case of XML, external entity injection, we're going to look for a case where somewhere in our application we have an insecure XML parser, and then we're going to try to use our static analysis tool to figure out, okay, where is user input coming in? How is it flowing through the application? Does it end up in that insecure parser without any kind of sanitization or validation? And so that's going to be the kind of typical workflow. But it's perfectly possible that at the time that the XML parser is kind of added to the code base, that user input doesn't yet have a path to it. So a traditional security tool at the time of development, it's not going to find a problem here. And a traditional security person would say, well, there's no vulnerability, there is no user data entering the parser, so yeah, it's not a problem. But it could become a problem. A month later, this vulnerable XML parser that was not secured might be called in a different context, creating a vulnerability. It could be copied and pasted into someone else's code by another developer. And all of a sudden, vulnerabilities will crop up. And so with a secure guardrail, we can take a little bit more of a proactive approach. Instead of trying to find a full vulnerability and detect it, what if we just find the insecure XML parsers and just identify those and say, hey, I notice your XML parser is insecure, let's secure it. And so that becomes a secure default, or sorry, a secure guardrail that tells the dev, hey, this is insecure, make it secure, thus preventing vulnerabilities now and also in the future. So this just becomes the kind of default behavior that we expect. So when we're talking about a secure guardrail, as I just said, a really simple guardrail is going to find where is there an XML parser that is insecurely configured. And there's 2 ways we could write a rule to do that. The first is we could write a rule that just looks for where is a XML parser configured with an explicitly like insecure value. And the second way is we could look for a parser that is missing security configurations. And so I'll kind of go over two different guardrails, those two different perspectives, and demonstrate some Semgrep rules that cover them. Sorry. Now, before we get into the rules themselves, I just want to jump into the cheat sheet that Peter and Vasily have created. It's a bit overwhelming at first, but to break it down for you, this is a summary of a whole bunch of research they did where they tried all 10 different attack payloads against these different parsers. And then they tested adding different security features to the parser to see if the attack payload still worked when that feature was set. So across the top here, we have 10 different XML parsing classes. So document builder factory is here in this column. And then off to the, on the y-axis, we have the security features as they're applied. So for the default configuration, out of the box XML parser, document builder factory is vulnerable to 4 attack payloads. If we were to turn on the configuration called feature secure processing, that would reduce the payloads to 0 that it's vulnerable to. And as we can see, what makes Java XML parsing kind of fun is these security features are not consistent across all these parsers. So feature secure processing fully secures these 5 parsers. For these other ones, it maybe does it, and for some, it just doesn't do anything. So it's critical to know what class we're trying to tackle when we're trying to see what features are being set or not. In the case of our first kind of secure guardrail, one where we look for where a developer has explicitly set an insecure value, I'm just going to write a simple rule that looks for this feature secure processing and see, has a developer turned it off? So let's get into that. So here I am inside of the Semgrep rule editor. For those of you who maybe not be familiar with Semgrep rules or writing them, when I'm looking at a rule in the editor, the rule itself is always off here to the left, and everything off here to the right is just sample code that I'm looking to match with the rule. We take a look at the examples here. Here's an example of a document builder factory that we build or construct, and then we set some security configuration on it. So in this case, setting that external parameter entities feature to true. If we set this feature to true, this is a feature that will allow you to include external entities in the XML, which is something that an attacker could abuse. So we want to make sure that developers are not setting this to true. I can always run the rule that I've created by clicking the run here. And Semgrep will highlight where it's matched the pattern in the code. So here, we're setting that to true, which is unsafe. Here, the developer's setting it to false, which is safe. So we're not going to match on it. When it comes to the actual Semgrep rule, Semgrep rules are written in YAML. They have a set amount of metadata that you'll see in every rule. So every rule is going to have an ID that identifies it, a severity, a message that gets printed out to the developer, and then a pattern block. And the pattern block is going to say, that's the actual rule itself, like what Semgrep uses to match patterns in your code. So in this case, I'm looking for any case where a method called setFeature is being called with the arguments to turn external parameter entities on. And so this is a super simple guardrail. It's easy for us to tell, hey, are you setting this feature? Are you not setting this feature? And then providing a fix is also really simple. And so that's the instance of a really simple guardrail. Now I could get into the more complicated use cases. Let's find cases where there are XML parsers that we don't fully secure. So if we're just using the default document builder factory right out of the box, it's not secure. And so if a developer forgets to add the security setting, which is probably likely, it's going to be vulnerable to certain entities. And so let's move on to that more complex rule. So here I am looking at a more complex rule. I'll click run here so we can see what it's doing. So in this case, we're looking for a case where we're creating a document builder factory and creating an XML parser from it, and then parsing with it. But the case where we create that parser and remember to set the security feature secure processing, which, if you remember, reduces all 10 attack payloads to 0, then we're good. We're golden. And so when we're writing a rule like this, this will probably require some research. It definitely took Peter and Vasily some research to figure out what are these things the developer should or could be setting. So the rule is kind of long because of that. The rule gets a little more complicated. We now have multiple patterns. So the other rule just had a single one. Now we have multiple patterns that build up using Boolean logic with each other. So at the top, we have a patterns block, which is an and statement. So it says everything under me must be true to match. And what must be true? Well, it needs to be a new instance of document builder factory. So anytime someone creates it and doesn't, so this is a not statement, doesn't set a feature that makes it secure. So here's that feature secure processing. There's another feature called disallow doc type decal that they could be setting. There's a few different features for this document builder factory that would fully secure the parser. Maybe they need to set 2 features to achieve full coverage. So we're including that in the rule as well. And so, we're able to quickly figure out where are you creating an XML parser and failing to secure it. And then we can tell the developer, cool, you're using an insecure parser. Please secure it by adding the feature secure processing. So that's the like simple basics of like a guardrail in terms of like what it can look like. Now I want to contrast it with like an actual XML external entity injection vulnerability detection rule. So a rule that actually sees, is that XML parser abused or ripe for abuse? So a rule like that is going to need to actually, first of all, detect that insecure XML parser like we were just doing, but also discover where is user data coming in and reaching it and being parsed with it. I'm not going to go into the super like details of how to write a rule like this. If you want to, Peter has a great video on it on YouTube called Catching External Entity Injection Bugs with Semgrep Taint Labels. And I'll leave that as an exercise at home for you to take. Oh. So let me go ahead and go to the rule. So here I am looking at an actual like vulnerability detection rule. So now we're interested in, again, this is in Java, but we have these methods that are kind of like endpoints for our application that have HTTP request parameters. So I have this parameter for files, for a file path, basically, to come in, or a stream or whatever. So user input is going to come in, and then we're going to construct a document builder factory. We're not going to secure it, and then we're going to parse that user input. And so Semgrep is able to track that data flow from the user input all the way to the file and say, hey, there is a vulnerability here. And so just a little bit different than just the guardrail approach. Now, to do these kinds of vulnerability detections, Semgrep has a second engine mode called taint mode. With taint mode, the engine doesn't just look for a simple pattern, it looks for the data flow between 2 different patterns. So a pattern where data comes in and a pattern where the data reaches and it's vulnerable. So when we're looking at a taint mode rule, there's always going to be a pattern sources block. So that tells Semgrep, hey, if data is coming in off of an HTTP request, that's what we're doing here, follow it through the application. And Semgrep is, semantically aware, it's knowledgeable about how Java works, so it's able to follow it from method to method until it finally reaches a pattern sink, so an endpoint. In this case, a document builder that we failed to secure. And so that's what a full-blown vulnerability detection rule would do. And if we're performing an audit of our application, we want to understand the risk of our application, this is what we should run. But it's a little less friendly for a developer. Now they have to figure out like, well, is that actually user-controlled data? Does that data actually get like cleansed or validated somewhere or combined with other things that render it, neutral? I guess I have to apply a fix. Where's the best place to apply that fix? And they could be looking across multiple files in the application. So the cognitive overhead to kind of now take a look at this issue and deal with it is a lot higher than that with the secure guardrail. And ultimately, I don't think either of these approaches are the best that they could be in an ideal world. There is more optimization that we could do as a team to make things easier for the developers. As we saw, no XML parser is going to be secure out of the box. So the developers are going to have to do some kind of security configuration on it. And that makes the kind of cognitive overhead complicated. Anytime that I create an XML parser as a developer, I now have to remember, oh yeah, there is that like security trivia about some kind of configuration, and I have to get like some XML constants, or it's something that just is going to get lost in the thousands of other little trivia that they need to know. So how can we lower the barrier to finding a fix? Well, we could partner with engineering to create a secure default that's custom to us. And I've seen orgs do this for this particular XML parsing issue. So whenever we have a secure guardrail, we're using a secure guardrail to enforce a secure default. And the secure default is what we want the developer to do by default. What is the secure thing they should be doing? And so the way that you could create a secure default for this XML parser is actually by wrapping it up into a custom class. So I've seen this deployed at a couple of orgs where they created a secure document builder factory. So they create this class that makes that document builder factory, sets the security features on it for the developer, and then allows the developer to get XML parsers from the factory. So it's super easy for the developer to use. They don't have to remember all of that trivia, and it makes life a lot easier. So if we look at it in use, let's go ahead and run my rule here. They create a new XML parser by creating a secure document builder factory, and then they parse with that now secured document builder. And the cool thing about this is that our rule becomes super simple. All our rule says is, hey, where are you using the out-of-the-box document builder factory? Don't. That's not what we use at our company. We use the secure document builder factory that is from our internal, library. So, hey, don't use that, use this instead. And so they can easily take a look at a fix like this. And again, the cognitive overhead is super low. It's a binary choice. Are you using this or are you not using it? And then the fix is just, well, just use it. So with this, I can kind of do an auto fix. I can say, hey, let's accept that fix. And now we're golden. And so that's the kind of the ideal end state for secure defaults. And the custom rules required to implement them can get pretty simple. And so, there's a few different benefits here. I've talked a lot about kind of the developer experience and the ease of use. There's some other benefits as well on the code quality side, right? There's a don't repeat yourself kind of thing. We're now getting rid of all of the code bloat that would be caused by that continued configuration of each new document builder factory. It's also more maintainable. If our security requirements change, if the implementation changes, there's one place to update it, which makes it really easy. And so that's kind of the picture in terms of like, what are secure guardrails as actual rules? How do they compare to a like vulnerability detection rule? And what are some like custom work that you can do internally to create your own secure guardrails, and really try to make life easier and the experience better for your developers, um, and hopefully reduce the work for yourself in the long run, because you're much more unlikely to get a call about, hey, like how do I like like triage this, and is this a false positive? It's very easy to tell if this is a false positive or not, and it's very unlikely that it is a false positive, um, compared to the actual vulnerability detection rule. Now, enforcing secure guardrails in Semgrep, we're kind of designed around this use case. You know, we still do have vulnerability detection rules, and we'll run those as well. But typically, when we run and expose things to developers, we want to do that within their workflow, and we want them to be that low-hanging, easy-to-fix fruit, to prevent vulnerabilities in the future. So let me move over to the Semgrep cloud platform. At the heart of any Semgrep scanning program is a policy of rules. So here I am looking at the rules that run when I run a scan. There's over 2,000 of them, and those rules run in different modes. So there's a monitor mode, and that's a silent detection mode. So for things that are more of a vulnerability detection that might be a little bit noisier or require more extensive triage, um, things in monitor will get sent back here to the platform for like the either engineering or your security champions to review. Um, what we expose to the developers are rules in comment mode, and those are going to be the stuff that is super low noise, that is our secure guardrails. And for those items, those are what get commented on a pull request for the developer. So that if they were to open a pull request, say in like GitHub, Semgrep's just going to run as a scan, as a check. Takes about a minute. It's really fast. And then any kind of issues get posted as comments for them. So here I am identifying the use of that document builder factory, which we no longer use at Capital Gains Group. Instead, we use our secure document builder factory instead. So we just raise that to the dev. And now they can easily, commit this suggestion, and the remediation is done. We also will surface things to them in the IDE. So whenever they save a file, Semgrep will run on the file. This is the exact same example from before, but Semgrep will run and then, in this case, identify the issues. So in this case, yeah, we've detected the use of document builder factory, and they're able to just kind of like apply a quick fix. So we can apply the auto fix, or we could ignore the finding. So boom, now it's a secure document builder factory. If we rerun the page, then we're good to go, and it's all secured. So that's kind of the picture in terms of enforcement with Semgrep. And then the last rule mode is a block mode, and that is for things that like we have a policy around. So, if, for example, we made our secure default, we created our secure document builder factory, that's now a policy within the org. Every developer should be aware that it exists and that they can reach for it. And so, it's something that we can create a blocking rule that will block the pull request, because we know it's not going to be noisy. We're always going to be able to tell when you're using the default document builder factory. And so we can create a policy and say, hey, you got to use it, or you can't merge your code. And that'll then prevent vulnerabilities in the future. Yeah. And so that's kind of the picture in terms of like enforcement. Oh, the last part I wanted to tackle was tracking. So secure guardrails is something that we think is valuable to track and report on. We want to know, like, are the guardrails we are creating, are they being effective? Are they being useful for the developers? So that's something that we track in the metrics and reporting that we do. So we want to know, for all of the rules for all the findings that get exposed to developers, how often do they actually fix them? Are our secure guardrails being effective and actually helping the developer lower the barrier to securing things? And additionally, how is that then affecting the amount of issues that show up for the developer versus security? So if we can fix, our findings before they reach the security backlog, that reduces the time that security then needs to spend on things. So those are really like the two big metrics that we think are good for tracking the efficacy of your program. But yeah, so that's kind of the spiel on secure guardrails, how to implement them with examples in XML. But guardrails don't have to be hard. There's plenty of examples of other orgs that we've done super simple guardrails. So here are some examples, just like using, for example, use an RBAC function before doing any user-facing operations. Enforce a specific like encryption library and prevent them from using another one. Or like don't use this specific secret manager instead of hard coding secrets, etc. It's super easy to implement these things, even if you're a smaller org, and it can help save you a lot of time in the future. And so that's kind of that. I have some resources linked here at the end, which David should drop in the chat. Links to that full Java research like blog post by Peter and Vasily with the parser cheat sheet. If you're interested in more about secure guardrails and concrete examples of how to implement them for a lot of different vulnerability types, we have a full secure guardrails course on Semgrep Academy. It's a free resource. It's free to sign up. And there's lots of examples. There's also courses on secure coding, how to use Semgrep, how to write Semgrep rules, etc. And then lastly is a link to a rule writing tutorial if you just want to learn the basics of Semgrep rules, how they work, and want to get started writing your own. That's all I have to present and talk about today. So I'll kind of open up the floor to any questions if anyone has anything that they're interested in maybe talking a little bit more about.
We kind of have one question in chat that I was typing to, but maybe we'll just talk about it live if that's okay. The question we had here is, how do you know a rule is actually a secure guardrail rule? I mean, I had a couple of thoughts, so I might just go first, and then
go ahead.
if there's stuff you'd like to add, I'll have you come in behind me. My first thought was like, really, I actually think this is a really good question, because really, I think any rule can be. I think the things that come together to make it really, really become a guardrail is about, number one, actually having a vehicle and a mechanism to get that to a developer. So we talked about shift left, and maybe this might actually almost be worth going back to the very early slide you had, in terms of like, though this is easy, this is hard, because I actually think that this is hard part is the part that kind of turns this into a guardrail. So like, one, we need a vehicle or a mechanic to actually get the alert to a developer at a timely manner. But two, we need to make sure that it's really accurate. We need to make sure that it is relevant at the right time. And almost most importantly, it needs to be nudging them in the right direction, right? So like what Jason showed, where there's the internal class and we can just directly auto fix the code for them. That is obviously best in class, because that requires no research work or activity from the developer at all, other than the click accept suggestion. And so this is the part that we think is really hard, is like getting that to them at the right time. And so we really build a lot of control into the product to kind of both allow you to extend and develop your own rules, as well as to control the interaction of what rules actually will pop up and have what interacts with them. And one thing we didn't focus on here that we're doing to make this really extensible is actually with our Gen AI add-in. So essentially, we have a feature we call Semgrep Assistant is what we call our generative AI component. Assistant has what we call memories, which are ways that you can essentially add context into the prompt chain that is going to kind of produce these generated auto fixes and guidance. And so that way we can incorporate some of your code samples and stuff in there in a way that's much more flexible than even what we showed here. Those are the things that stand out to me immediately. I don't know, Jason, if you have other thoughts around, what kind of is the special sauce that makes a rule into a guardrail outside of that?
Yeah, I think like guardrails should be kind of a good guardrail should be a binary decision. It should be really easy to tell, are you doing the insecure thing or are you doing the secure thing? So with the configuration, it's really easy to see, are you configuring it or are you not configuring it? So code review should be easy. That's the first part. And then the second part is that the fix should also be simple. It shouldn't ask you to figure out, is this a real vulnerability that poses a risk? It should ask you to do the secure thing despite the possibility of risk. So that default practice, it becomes a habit and becomes an organizational standard, so that it prevents the possibility of any vulnerabilities cropping up in the future. I think those are the two big components for me.
Those are really great. No, that's I think very well put. And so for everybody's context, I think that's all of the questions that we have.